In example 2, we want to rewrite as a single trig expression. So we want to find the exact value of the tangent of 32 degrees plus the tangent of 13 degrees over 1 minus the tangent of 32 degrees times the tangent of 13 degrees. The first thing we have to do is figure out, is this a sum formula or a difference formula? So let's take note, we have a plus sign on the top and a minus sign on the bottom. Let's go back and look at our formulas to see what we have. So if we go up to the top here, the tangent of A plus B, we're adding on the top and subtracting on the bottom. And A minus B, we're subtracting on the top and adding on the bottom. So the one that lines up with what we have going on is the tangent of alpha plus beta, or A plus B, however you want to say it. So this is the one we're using. So we're going to go back down to our formulas, and we are going to rewrite this. This is the same thing as the tangent of 32 degrees plus 13 degrees. So we're going backwards from what we did in example 1. And then we can add those together. 32 plus 13 will give us 45. So we have the tangent of 45 degrees. And if this number comes out to be one of your special right triangles, evaluate the tangent of 45 degrees. And we know the tangent of 45 degrees is just 1. Let's try another one in example B. We want to simplify the sine of x times the sine of 3x minus the cosine of x times the cosine of 3x. If we go back to look at our formulas on the top, we need sine, sine, minus cosine, cosine. So let's see what we have up on the top. If we take a look at the top, in the first one we have cosine, cosine, minus sine, sine. And in the second one we have cosine, cosine, plus the sine times the sine. So let's look one more time at what we have in our problem. We have sine, sine is positive, and cosine, cosine is negative. So keep that in mind. Sine, sine positive, cosine, cosine is negative. If we go look at the top, again, we don't have our sines first in either one of these, but the cosine ones are the ones that have the trig functions together, 2 cosines together, 2 sines together. And we need 2 sines to be positive, but we need the 2 cosines to be negative. So basically what we want is the complete opposite of what we have right here. So in order to get my sine positive and my cosine negative, I can factor out a negative 1. So let's see what we do with that. So if I come back down here and I factor out a negative 1, I have a negative that makes my sines negative, negative sine x, sine 3x, and it makes this a positive cosine x, cosine 3x. And then what I can do is I can rearrange so that it looks like the formula's on the top. Notice the formulas on the top, both of those cosine ones start with the cosine first. So since I'm adding, I can add in any direction or in any order. And I can rewrite this as cosine x cosine 3x. My sines are negative, so minus sine x sine 3x. Now if I go to match it up, I have cosine, cosine, minus sine, sine. If I look back up on the top, cosine, cosine, minus sine, sine is coming from the cosine of alpha plus beta. So that's what I'm using down here. So now what I can do is I can rewrite this. I still have my negative that's out there, and then I have the cosine of x plus 3x. So I can add that together, and I get negative cosine of 4x as my final answer. Since there's an x within my angle, I can't evaluate it, and I'm done where I'm at. If you have questions, let me know. Otherwise, I want you to go ahead and try this. Just keep in mind, you don't always have to take out that negative. You're only going to take out or factor out that negative if you don't have the order that you want when you start. So go ahead and try this. There's 2 of them. If you did letter A correctly, you should have gotten negative 1/2. And if you did letter B correctly, you should see that you get negative tan of x. If you have questions on either one of those, let me know.